Hi, everyone. So, what we're going to start talking about today is navigation. And navigation will use direction and length, okay, just like we've been doing with law of sines and cosines. But of course, just when you got a handle on things, a couple things are going to change. So, first of all, if you notice here, um, when we work with our angles in pre-calc, mathematicians start with 0 over here and we go counterclockwise to measure our angles 90, 180, 270, right? We all know that. But when we're working with navigation, we're working with something called bearing. And bearing measures the angles a little bit differently. So we start with our 0 being here up north, and then we go clockwise 90, 180, 270, and 360. So we're going to have to retrain our brains to be able to think in terms of navigation and bearing that the 0 degrees is north, and then we go clockwise around. Of course, every right angle is still 90 degrees, so across from 0 is 180. So not everything changes. So let's go ahead. We're going to start kind of training our brains to do some of these. So the first thing we're going to look at is something with a bearing of 120 degrees. So, as we just talked about, this would be 0 degrees, this would be 90, and this would be 180. So a bearing of 120 degrees will go 30 degrees past 90. So it would be something, usually a bow, a plane. That's kind of what bearing is used for. It's for navigation. So it would be traveling 30 degrees past that 90-degree mark. So going a little bit south of east. Okay, this is east and it's a little bit south of that. For a bearing of 85, again, here's our 0, here's our 90. We're almost going east, but we're going 5 degrees shy of east, so a little bit north of the east. It's hard for me to fit my numbers in here, but I usually write them in there 5 degrees, okay? Or you could put bearing 85, you can put that here, whatever you like. Okay, number 3, a bearing of 250 degrees. So we think 0, 90, 180, and 270. So it's about 20 degrees shy of this. So it would be going this way. And we have a reference angle of 20 degrees right there. And if this is 270 and we have a bearing of 300, we're going to be going all the way about 30 degrees past the 270. And that would be our bearing of 300. Okay. So there will be some other ways that we will express the direction in which our boat or our plane will be traveling. And sometimes we're going to use the words north, south, east, and west. And I know you're familiar with these. Some of you say never eat soggy wheat. Okay, so if we write something like this, this is north, 60 degrees east. The way we actually say it is 60 degrees east of north. So I kind of say, all right, if I was going north and now I float over in the direction of east, that would be a 60-degree angle this way toward the east. Okay, so you think, all right, I'm going north, but not really. I'm actually 60 degrees in the direction of east. Okay. And again, when we're doing these problems, we're going to have to think about if this is 60, this is 30. Sometimes things like that are going to be really helpful for us. So let's turn to the next page. Okay. And what I'd like for you to do is I'd like for you to turn the video off and see if you can do these problems. Okay. And then when you're done, turn them back on and check, and we'll go over a couple of them. Okay. So stop this video. Okay. Let's take a look at these. A couple things I do want to point out. Number 3. I don't know. We don't really use that very much. There's a much more efficient way to write that. So this one, 250 degrees east of north. If you think about that, if this is 180, we could have just said whoops, I don't have my pen here. We could have just written this, okay, saying to go 70 degrees west of south. But sometimes you'll see things like this that, aren't super efficient. Same thing with number 7. I wouldn't typically write something like that. I would say something like to go 30 degrees south of west. Okay, or I could have said 60 degrees west of south, right? Because that would be the same thing. Okay, so if you're feeling good about those, let's go to the next. Okay, so this goes straight with our directions, okay, things that we probably use in real life. So if you're going northeast, you're going right smack in the middle of the north and the east. So here's north, here's east, and there you go. That's northeast. These two angles would be congruent, and they're both 45-degree angles. South would be going just directly in the, south, so directly down. East, there you go. That should be easy. And southwest, kind of like northeast. Okay, southwest, here's your south, here's your west. It's right smack in the middle of the south and the west. So again, we have congruent angles, so these are each 45 degrees. So that should be pretty easy for you. So let's continue. So this is all going to lead up to us solving some word problems. And of course, when we solve our word problems, we need to be able to draw our diagrams. So the first example I have done for you is a plane traveled at a bearing, okay, a bearing of 135 degrees. So we think zeros here, 90s here. So this would be 135 degrees, right? 45 degrees past 90. The second example I have drawn out for you is that hikers walked in the direction of 40 degrees west of south, which could also be written like this, 40 degrees west of south. So you think, all right, if this is south, going this way, I have to be 40 degrees toward the west of that. So this is the direction that they're walking. And letter C, I have a couple things, and this is going to be the most challenging. So we have a plane that travels 500 miles an hour for 2 hours. So first of all, 500 miles for 2 hours, that's going to be 1,000 miles at a bearing of 240 degrees. So let's think about this. We have a bearing of 240 degrees. So we give ourselves a start point. We think, okay, 0, 90, 180. This is 270. So it's 60 degrees past the 180 degree mark, right? 240 minus 180 is 60. So here's where the plane first traveled. And we see that it traveled for 1,000 miles. Now notice I put the 60 here. I didn't put 30 up here because now here's what happens. The plane changes direction. So we make a new north, south, east, west. And it says that it's going to travel at 450 miles an hour for 90 minutes. So 450 times 1.5 gives us 675 miles at a bearing of 310. So we look at this and we go, all right, well, this is 0, 90, 180, 270. So 310 is 40 degrees north of west. So that's how we got this little line segment right here. Okay. And very often the questions that we're going to ask would be, how far is the plane from where it started? That would be this segment. Okay. We might also ask, at what bearing should it fly in order to get back to where it started? So we would be thinking of something like this. Here's 0, here's 90, here's 180. And we're going to be using law of sines and cosines to do this. So doesn't that sound like fun? All that you've been learning, we're now going to put it into play. So what I'd like for you to do, I think you already know, I want you to pause the video. I want you to take some time to see if you can do A and B. Okay, so just do A and B, and then we'll work through those, and then we'll look at C and D, which are a little bit more challenging. So pause the video. Okay, so I have the basics written down for these. So the first one, we have the plane traveling at a bearing of 330 degrees. So if we think about what this looks like now, where our degrees land, if this is 200, 330 is going to be 60 degrees past that. Okay, so I'm going to put the 60 here, but really this is a 330-degree bearing. Okay, we can even write that up here, 330 degrees. Okay. And just FYI, this angle right here would be 30 degrees. The next one, it says the hikers walked in the direction of 20 degrees north of east, which we're really just going to be writing like this because that's the most efficient. So you have to start at the end, okay? 20 degrees north of east. So start with east. Okay, if they were going east, they'd be going this way, but they're actually 20 degrees toward the north of that. Okay, so this right here is 20 degrees north of east. Okay, so now these get a little bit more challenging because now we're going to have a couple things that we have to draw. So let's read this one. It says a boat traveled along a straight path with a bearing of 120 degrees at 60 miles an hour from 12 to 3:30. So this all goes together. It then turned and traveled until 5 o'clock at a bearing of 60 degrees. So let's see, we have to give ourselves a little starting point here. And if we think about a bearing of 120 degrees, okay, that's going to be 30 degrees past 90. So here's 0, here's 90. So it's going to be traveling 30 degrees past 90. Okay, I'll write a little 30 in here because I think that'll be helpful. And of course, we have to do 60 miles an hour times 3.5, right? 60 times for 3.5 hours. And that comes out to be 210 miles. Okay, and again, that was just 60 times 3.5 hours. Gave us 210 miles. Then it turned. So again, what I like to do is I like to give myself another little plus sign here. And it says now until 5 o'clock. So it's going to be until 5 o'clock. So 60 miles times 1.5. It's going to travel another 90 miles with a bearing of 60 degrees. So if this is 0 and this is 90, this would be a bearing of 60 degrees. There's a 60 right in here. Okay, so this is where it landed. And again, this would be 90 miles. Now, it's really important if you can try to draw these to scale. Okay, this one certainly isn't perfect. I should have probably made this one a little bit smaller. I would also say don't draw your diagrams super tiny because you're going to need to be able to do some things. For example, I told you earlier that we're probably going to have you find the distance from here to the start. Okay, so that's going to be important. We're going to fill in some information here. Even though we're not solving this problem, there is some more information we can fill in. So you can clearly see that this 30-degree angle kind of got cut here. But we know if that's 30, this is 60 degrees. And remembering two parallel lines cut by a transversal, alternate interior angles are congruent. So if this is 60, this angle right here is also 60. And just looking ahead, we now have side, a 120-degree angle, and side. So we can use law of cosines to solve this. Let that sink in for a little second. We're not solving it, but that does set you up for how we would solve it. I want you to pause the video and see if you can do letter D. Okay, you've got this. Take your time. Okay, let's walk through this one. So it says you travel in a plane at a bearing of 240 degrees for 300 miles. So think about this. If this is 0, 90, 180, 270, we're going to be going 240 degrees for 300 miles. And again, let's think 240. That would be 60 degrees past the 180. So maybe we write that in there. From there, we turn. So I like to give myself another little plus sign. And we're going to travel north for 550 miles. Okay, so that's all the diagram we have. But again, the question would probably say something like, how far are you from where you started, which would close up the triangle this way? And it might also ask, what direction should you fly to get back home? Okay, so that's what that triangle would look like. So, what I want you to think about is just really starting to memorize where the angles are. Maybe you need to make a little note card and look at it a few times a day. I want you to really think about the fact that we have 0 up here, 90, 180, and 270. Okay, and of course, 360 right back up here for our bearings. Of course, I think you already know this, but north, east, south, and west. Okay, we're going to start retraining our brains so we can work on these navigation word problems. Take a look at them. We've got a couple I'll do with you, and then we have so many more. So have a wonderful day, everybody.